So domain and range of linear functions. Remember, a linear function is just a line. Domain and range you will actually use for every single math class from here on out. You should have talked about it in 8th grade, but um, if not, it's okay. Whatever your excuse is for what happened in 8th grade, that's fine. But we are going to learn it. So domain and range. Domain is all possible values for the independent variable or for the x, for x values. Remember, independent is x, dependent is y. So range is all possible values for the dependent or y. The easiest way I know to remember, if you're thinking about, and I'll move it over in just a second. If you're thinking about the x and y axis, domain are the values for the x-axis, and range is for the y. So range is like the rain falling down. Range is range. Rain falls down. It doesn't fall horizontal. So it falls down. So range is talking about the y-axis. That's one of the only ways I really can think of it. If you have a better way, you should tell me so that I can tell everyone. So domain is along the x-axis. It's all of the values for x. Range are all the values for y. So there are a couple of ways you can see it. So if I told you, or if I gave you the points 2, 6, -8, 4, -4, 2, and 0, 5. And I said, give me the domain and the range. So the domain are all x values. So I'm going to go ahead and write them. So x, x, x. Think about a coordinate. It's always written as x, comma, y. So domain is talking about every x value you see. And you always want to list them from smallest to largest. I'm going to go ahead and just write them all out in this order first. So it's 2, -8, -4, and 0. Or the correct order to write this, and you always put it in little brackets. I know those are hard to write. Yes, I'm good at it. I get told all the time. So you want the smallest number first, so it would be -8, comma, -4, comma, 0, comma, 2. Oops, see, sometimes I can't write them either. So, curve, point, curve. So -8, 4, 0, and 2. Those are the values for x in this situation. Okay, now I'm going to go ahead and do the y values. So, oh, I don't want to use that color. I'm going to use purple. So I'm going to use, these are the y values. So I'm going to go ahead and just list them first. 6, 4, 2, and 5. Now if you list them in order from smallest to largest, 2, 4, 5, and 6. Those are your values for y because they're the second value. Okay? Now, if I said that there was, if I was talking about a situation, I said number of pizzas and the cost. So if I was talking about number of pizzas and the cost, and I said one pizza was $13, 2 pizzas are 21, and 3 pizzas are 29, and I asked for the domain. So again, domain are for the x values or the independent, so number of pizzas. So I could say 1, 2, 3. And then the range would be 13, 21, 29. Now, this is just listing the numbers. And I want you to think about this for a second. They have ordered a fourth pizza? Could you order 5 pizzas? Could you order as many pizzas as you absolutely want? So think about that for a second. So you always want to ask yourself, do the values stop because they just stopped listing them? Like they didn't want to list all the way to 100? Or did they stop because you really can't have any more? So the domain starts at 1, 2, 3. You could have ordered a fourth pizza. You could have ordered a fifth pizza. Now, will a company let you order 2.5 pizzas? No, I've never found a place. Yes, you can get slices, but it's a whole slice. I can't ask for half of a slice. So when you start talking about domain and range, you have to think about, can I order half of them? Like if I was, I'll show you another example in just a minute. So you can also list these and say your X values. So you can say X is any number greater than. Remember that symbol right there that you saw when you were, and this is domain. X is greater than 1. So you can order any number of pizzas greater than or equal to, because you can actually order 1 pizza. X is greater than 1 as long as it is an integer, which just means whole number. So you can order any number of pizzas as long as it's more than 1, and as long as it's a whole number. You can't order half of a pizza. You can't order 3/4 of a pizza. Now, range, you would do the same way. What's the lowest you can spend on that pizza? Or did they tell you you can spend? So 13 is the lowest. What is the largest? 29. So or 29 is just the highest they said, but if I ordered 4 pizzas, then my price would be higher than 4. So you would again just say y is any number greater than 29. Okay, and in this case, they're all whole numbers or integers. There are no decimals. Yes, you could have had 13.5 or $13.55. And then in that case, we wouldn't have written this part. But since they are all integers, you can just say, oh, and I wrote 29. Darn it. I'm sorry. I'm messing up. So y is greater than 13, not 29. 13 is the lowest. So you would say integers. So y is greater than 13. Okay, now what if I was talking about time and distance? Oops. Distance from school. So if we were talking about leaving for a field trip to Albuquerque, and we'll put hours. And so 0 hours, well, of course, we've left or have a distance of 0. 1 hour, we have a distance of, let's say, 70 miles. 2, we have a distance of 140 miles. Okay, so again, let's do domain first. So domain, let me see if you can see that color. Yeah, that's not too bad. So domain, I'm going to go ahead and list them first. So it's 0, 1, 2. Now, we need to think about it. So and we're going to write it as an inequality. So again, this is x, time is always x, distance is y. So x, so my time is so it's 0, 1, 2. So we can't have negative time since we left school. So you know it has to be greater than or equal to 0. And then if we think about it, x is greater than or equal to 0. If you think about it, can you have half of an hour? Can you have 1.5 hours? Is there a distance when I am 0.5 hours awake? Yes. So we're not going to say the thing about integers or whole numbers. It would just be any number greater than 0. It could be 2. It could be 2.2. It could be 2 hours and 1 second. It doesn't matter because it's time. You can't have half of a pizza, but you can have half of an hour. Okay, and then range. Again, oh, that's one's terrible. So 0, 70, 140. So if you look at this, your y values are greater than 0 because you can't have a negative distance. And then you have to decide, do you need to put that, it's called a stipulation or whatever, restriction, I guess you could call it. But do you need to put a restriction on this? Can you go 1 mile? Can you go 1.5 miles? Can you go 68.7 miles? Of course you can. So just like time can be in between here, distance can be in between here. So it would be y is greater than or equal to 0. Now, let me go, we're going to do another one. So, actually, no, I'm going to talk about this one. If I said for sure that we were going to Albuquerque, or that we were only allowed to drive for 3 hours, or whatever the rule is, you would have to put a stopping to this. So if you said, and I'm going to just turn the page. If I said time was between time could only be from 0 to 0 hours to 3 hours. So if I said that we could only travel for 3 hours, or that's how long it takes you to get to Albuquerque, you would have to write it as 0 is less than or equal to x, and I'm going to explain this in just a second, less than or equal to 3. You always write it as this. This is your lowest. This is your highest. So if there is a highest, that's when you have to write it like this. Notice x is just sandwiched in the middle. The 0 is less than your x, which is less than or equal to 3. Remember these. I know that you probably had a teacher at some point that's called them an alligator. But this is a less than because you come up to the smallest part first. If you come to the biggest part first, it's greater than. If you come to the smallest part first, when you read from left to right, it's less than. So 0 is less than or equal to x, which is less than or equal to 3. So if it has a time restriction, where if you were talking about a race and they see how far you can go in 10 seconds, or they tell you that, like if you're buying shirts and they tell you the maximum number of shirts you can buy is 5 because it's a sale, then you would say from 0 to 5. So that is one case where it would be a little bit different. So if it starts and then stops, or if it has a lowest and a highest, that's how you would write it. Now, you will also see graphs when talking about domain and range, and I promise I'm almost done. So when talking about domain and range, so I'm going to plot those points that we just had, 2, 6, 1, 2, 1, 2, 3, 4, 5, 6, negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and 4, 1, 2, 3, 4, negative 4, 1, 2, 3, 4, and positive 2, and 0, 1, 2, 3, 4, 5. So if these are the same values that you just did, but if I gave you points like this and I said, what is the domain, what is the range? The domain, again, is talking about the values along the x-axis. So domain. So I'm going to look and count along the x-axis. So I have -1, -2, -3, -4, -5. So we have 1 at -5, -6, -7, -8. We have 1 at 0, and we have a value at 2. I thought that was a -4. I did. I plotted that point wrong. -1, 2, 3, 4. Sorry. Oh well, it really doesn't matter. Those last points really don't matter that they were the same. I just picked 4 points. So we have a value at -8. We have a value at -5. We have a value at 0, and we have a value at 2. So this point right here is at -8, 1, 2, 3, 4. I'm looking at that x value. This one is at -5, 2. I'm looking at that x value. That's why I just wrote them along this. So my domain is -8, -5, 0, 2. Those are my x values. Now if I'm doing range, I'm going to look at the y-axis. Let me move my hand so that it can focus. Okay, so I'm going to look this way. So I have one that is at 2. I have one that's at 4, one that's at 5, and one that's at 6. So my range would be at 6, and write it in order, sorry, of smallest to largest. So 2, 4, 5, and 6. Because I'm looking at those y values of those coordinates. This one is at 5, this one is at 6. So all I care about for range is looking where it's at along the y-axis. Domain is along the x-axis. Okay, so that's domain and range.